All right, so this video is going to be about double angle formulas. They are given to you right here. I would say that it is good to know the double angle for sine, and it's like a nice to know of these ones of cosine, but it's more important to be able to use them appropriately. So looking at this first example, I know that the tangent of theta is -3/4, and theta is in quadrant 2. So -3/4, actually that would be the positive side here. A 3, 4, 5 triangle is what we would have. And it wants me to find all of these other trigonometric identities here. So if I wanted to find the sine of 2 theta, I would say that that's equal to 2 sine theta cosine theta. And I'm using this identity right here to do that. That's going to be 2 times, well, the sine of theta, using this as my reference angle, is 3/5. And the cosine is -4/5. And I'm just going to leave this in like unsimplified form just so you can see how the formulas work. Cosine 2 theta, I can use any of these that I want to. So I could use cosine squared theta minus sine squared theta. So that's going to be -4/5 squared minus 3/5 squared. I could use any of these other ones as well, and you'd end up getting the same simplified answer once you go ahead and apply those squarings and then combine. Maybe here I will do this, so this would be positive 16/25 minus 9/25, and so we'd end up getting 7/25 as our answer. All right, and then let's do tangent of 2 theta. So that's going to be 2 tangent theta all over 1 minus tangent squared theta. So I already know tangent theta, that's given to me, so that's 2 times -3/4 all over 1 minus -3/4 squared. Again, I might just want to leave this in unsimplified form, or if I wanted to go ahead and simplify, I'd have -3/2, 1 minus 9/16. That means the bottom, if I make this 16/16, is going to be 3/2 all over 7/16 multiplied by the reciprocal, and I end up getting -24/7 as my answer there. If I wanted to use the double angle formula to write cosine of 6x instead in terms of cosine of 3x, well, let's go ahead and see cosine of 2, let's write it in thetas just so that we're not using the exact same variable. And I need this to be cosine of 3x. So let's use this one right here. So that's going to be 2 cosine squared theta minus 1. And I chose that one because I still want this to be in terms of cosine. So I didn't want to choose the ones that had sine with them. That just wouldn't make a whole lot of sense. So I'm going to use the one with cosine. All right, so if I have cosine of 6x, that is the same thing as cosine of 2 times 3x. And so I can say, well, let's let theta equal 3x. So that's going to be 2 cosine squared of 3x minus 1, and that's going to be my answer here. All right, let's go ahead and look at this as an identity verification type problem. I could kind of take this one of 2 ways. I'm actually going to go ahead and use the right-hand side. So remember, if you have sine plus cosine and sine plus cosine, that we would end up getting sine squared, sine cosine, and then cosine squared. So let's see at 1, I'm not going to worry about writing that actually. I'm going to say that that is equal to, expanded out, sine squared plus 2 sine theta cosine theta plus cosine squared. I know from my Pythagorean identity that this combination of sine squared plus cosine squared is 1. And then this piece right here is the same as sine of 2 theta. And so I get this as 1 plus sine of 2 theta, which is exactly what I would like.